Welcome again. We're back again for another build stream. Today we're doing some droid making. We've got this cool dual camera set up right now. We've got a camera over there. We've got a camera over here. Yeah? I pointed at the camera, but you guys can see it. That's okay.
Pointing here.
Well, here we go. Got a camera down here. We got a camera up there. So we've got a dual camera setup. It's real high budget stuff going on right now. And we've got our droid. Okay, guys? I've partially assembled a little bit of this stuff, the stuff that was a little bit finicky to put together, but mostly it was pretty simple, just slipping the servo motors in where they go and then screwing them in place with the little screws that came with it. Now, one thing I did mess up was that I used the wrong screws. Make sure you guys use the right screws. The tiny screws go for the little swipers. So I'll grab one of these guys here. So they have like these little wiper things on the top of them, and that's how the motor actually controls whatever it wants to move. There's a screw that comes with it. It looks like this. I'll show you. It's like, it looks like there's nothing in my hand, but there's actually a tiny little screw. Okay, don't mix those up with the mounting screws. The mounting screws actually screw the leg into place, and I can show you where those mounting screws are. There's one here, right there. I actually ran out of mounting screws, but the mounting screws are not as important as this little tiny screw. This little tiny screw is absolutely crucial. So don't lose that screw, guys. Don't lose that screw. Okay, so let's put one of these together, because I actually left the leg attachment process to show you guys how it's done. Okay, so first thing we did was we assembled these legs, which were two halves screwed together at obtuse angles. I wish I had another one to show you guys, but the rest of the leg pieces are currently printing, and hopefully it'll be done by the end of the stream. But these guys have little holes in the back.
Actually, we had a spare motor, right? We can pull that out and kind of demo how it kind of goes.
Oh, here it is. Here's the spare motor right here. So this guy goes and kind of slips inside, but there's actually like a little
up there to the camera.
Yeah.
There we go. So this is a mount for the motor.
Yeah, and it's got like screws in the back, and it screws into another duplicate bracket at like a 45 degree angle. Or 90 degree angle. And there's also like this little plastic bearing inside. Let me see if I can pop that out for you guys. I'm gonna post the where I got the design from in the chat, so you guys can check it out. And when I re-upload this onto YouTube, you guys will also be able to see that design on YouTube. Okay, guys? Pop that in there. Hi, Mew Mew. Hello. Thanks for joining us.
I care.
So we've got the little bearing in there now, and I'll show you how this side slips inside. So this is in there. There's two different sides. There's the one side with the bearing, which you guys can see has got like a little circle in there. Right? And then we've also got this other side. And on this other side, it's got like a little ditch. I don't know if you guys can see that. It's got a little like... Oh, shoot.
Tilt this in.
I'll put a little bit of shade so you guys can see. There's like a little indent in there where the tongue sits. I call it the tongue. Some people call it the wiper. But each of these servo motors have a little wiper that goes along with it. I might as well show it with... I wish I had an extra wiper. I feel like I used all the wipers already. Here, I'll demo with one of these guys. Here. So, you can see on here, it's got this little wiper, and this wiper is the current position. Well, it kind of points to the current position of where the servo is. It has a maximum distance it can go this direction, like that, and it also has a maximum direction that it can go that direction, like that.
So it's about 180 degrees roughly that a servo can actually twist back and forth.
Yeah.
And you don't want to go over the limit because you strip the gears if you try to force them.
Yeah. So with that limited movement, we can actually do quite a bit, and we're actually going to try and mount all these up and try and get them all to move in synchronicity. We got a synchronized walk. We will hopefully show you guys some of the building process and give you guys a good idea what it would be like for you guys to make your own. So we use a 3D printer to make all of these little like plastic parts. So all this plastic stuff was made on a 3D printer, and the design I chose was, like, to me, really simple and minimalistic. Because you guys don't want to waste too much PLA just printing up the body. You guys can see that this is pretty much just like a little skeleton that just holds everything together. I'll show you guys from the other side. This is like a long backbone that's held in by the mounting screws. And then there's like these little hip pieces. He calls them the hip from the design. But they're like little squares that hold the servo motors in place.
I'm going to give actually people a sense of how it's going to work. If we kind of hold it up, there's the body. It's going to be on.
Yeah, and
here.
Actually, we can attach one of these legs if you want. You want to do that?
Let's demo that to people. Let's actually show people how it's going to attach.
So I'm going to twist this back in a position like that. And actually, that little screw there has got to go in to here. So we'll do that in just a second. So I'm twisting it here. You can see that this little leg here, this little fin, I twisted it one direction. That's all the way that direction. And I twist it back the other direction. And what I'm trying to do is I'm trying to get about half and half between each extreme position. So let me pull this one out. This one seems like it can move over just a tiny little bit. I think that'll be about half and half. Let me double check now. Move that over. Just twisting it, twisting it, twisting it. And that seems about 50 now. Okay, that seems good now. So I'm going to pull it out to here. And I'm going to... Yeah, do you mind to hop in the chat, Alan?
Yeah, give me a second.
And so this part is the interesting part because I kind of have to snap it in here. But if you guys can kind of imagine, this is actually going to go like that in there. So here we go. I'm going to have to gently lift up because the PLA is a little bit flexible, but then it just snaps in place. And now without the fin in there, you guys can see it's all wobbly. Like, it's all wobbly, right? But once we put that fin in there... There we go. We got it going on the other stream, guys. You guys can hear that. We're lurking in the stream, guys. We're in the stream. Uh-oh.
Here we go.
Here we go. Uh-oh. Okay, so can I borrow that deboring tool? Oh, here it is.
Yeah, right there.
Now, okay, so this is a little special tool for when you do 3D prints. It's got like kind of like a blade here. This part is a little bit sharp, but if I bring it up close to the camera, you guys can see like the tip is rounded, so that it's not. I mean, it's like less dangerous than doing it with like a razor blade or something like that. This is a really nice little tool. And the thing that's giving me problems is this little hole here, where the fin is going in. So I'm just going to use this guy to remove those burrs. Let's see if I can get in there.
Yeah, the hole's a little bit small, but you just want to open it up a little bit, and this is going to carve out a little bit larger hole.
Yeah, and that way we'll reduce the friction of the movement as well, because it'll move a little more freely without all those little pieces of plastic in there. Because during the printing process, whenever it stops and starts, it sometimes leaves a little bit of material behind. So it results with all these little bumps in there, and that can sometimes hinder projects that need to move. In this case, we really need to move. So here we go. Let's try and get that in there now. Oh, I'm getting so excited.
It's coming together.
It's all coming together. Aw, yeah. Okay, so now that it's in there, I gotta slip this fin into place, like so. And I'm gonna press it on that hole until it snaps in there. Oh, it snapped in there good. And I can tell that it's a good fit because without even screwing it in, I can move this back and forth and you guys can listen.
I don't know if you can have a little bit of extraneous noise. You can hear that, yeah.
It's actually twisting the gear. Hopefully that you guys can hear that. It's actually twisting the gear inside, which means that it's engaging properly. If it doesn't engage all the way, you're going to find that it doesn't twist that gear inside. And you want to be really gentle if you're going to twist them back and forth. You're not really supposed to do that, but I do it anyways because I'm a rebel. Yeah, if you're gonna do that, just be gentle with your servos and make sure they're not plugged into anything. Because it'll make.
Yeah, you don't want to try resisting the motor when it's trying to turn. It
Yeah.
could strip the gears, but it tries to force its way to a bigger angle, but you don't allow it to.
Yeah, you want to be really gentle with them and don't force them.
Unless you have metal servos, a little more robust, but we're not at that stage that we want to spend that amount of money on a metal servo.
We do have them, guys. When we get to affiliate, maybe we'll do a rebuild. Or like, I don't know, a follower count. Maybe when we get to like, I don't know, 100 or 1,000 followers, maybe we'll make a complete rebuild with metal ones. That's going to be interesting though, because I'm gonna have to create a good new model. Because again, this is somebody else's model. I will post it in the chat if anybody requests it. And when this gets re-uploaded to YouTube, you guys will be able to look in the description to find the model. I'm not posting it up right now because I'm just in the middle of assembling it right now.
We're just prototyping, just getting a sense of how it's going to work, and then we'll do any additional tweaks later.
So that's one leg completely assembled right here. Now, it's going to be a little bit of a while before we're able to completely assemble the whole thing because the last pieces are currently being made right now.
So maybe we could,
which is kind of insane,
maybe
right?
Just show people, I guess, a 3D printer possibly, the status.
Yeah, sure. We can show that.
Maybe we should open another window on that.
I have to create another overlay for it though.
Yeah.
So,
patience, people.
Sorry, guys. We're still getting used to doing the build stream. Every week we get a little bit better, right, guys? So I guess should I create a new overlay for it, or
actually,
just
what is that? You can open
duplicate it, maybe.
Drag a tab, I guess, for Octoprint, maybe.
Ooh, I can do that.
Yeah.
So I'm going to grab Octoprint, drag it off.
Yeah, and then you can just have it focus on that particular window.
And then just this one, copy like that. Will that do it?
Let's see.
No?
Nope. Okay.
Just please log in.
Oh yeah, it has. So we actually can we just maybe we could stream the URL for just the video? I think. Right click on the video.
Remove this one,
Yeah, remove that one.
or remove the properties, or something. So how do I do this one?
Yeah, right click on the image.
This one?
Can we? No, I guess we can't cast it. No, doesn't quite work out.
How do we get this? Just this tab though.
You should be able to share that particular window, so we can share.
Maybe not by doing it like this.
Not like that, no.
I'll try it a different way. Let's try window capture. Sorry guys, I'm still getting used to doing this.
Yeah, there we are.
Can we like maybe do a filter and just a crop?
You can change the view of that. Yeah,
Crop.
That looks good.
And then bottom. And then top.
Probably crop those black borders on the side out too.
Oh, crop them. Oh yeah, yeah.
Yeah.
That and then.
Oh, that's good.
That?
Yeah. And below the white on top and bottom.
Yeah, we can do that too.
Yeah.
250. 275.
That's good on top. So yeah, that's a nice view for people. You can just see what's actually printing.
Perfect. Alright guys, so here's the actual print that's going on right now. Guys, we're going high tech right now.
Put in this corner.
In this corner here?
Yeah.
This is the chat though.
Chat. Oh, okay, for the other side. So we'll move things around. There we go. Like that. You can see it here. You can see, so that is being printed to make more shoulders like this.
Yeah. That's literally the parts for it. This is cool. Guys, this is incredible because we're doing a whole new thing now. Actually, you know what we can do? We can actually, if I move this Octoprint underneath the build stream, I can move it like that. Although then you can't read any of that text.
I'm going to shrink it down, just maybe move it to that corner.
That?
Yeah. People can follow the progress of what's happening down there.
Okay, there we go. Now we still got enough room to do the rest of this.
People move over here.
Oh,
do the build. Yeah.
Okay, so give me a second. I'm moving in here. Okay, so now let's attach the next leg. Okay, so here's the other leg here. You guys are going to get to see how one of these legs is put together once the legs are finished printing. It says, look, it looks like it's got about 2 hours left on the print. So
it doesn't take that long, but we'll see.
well, we shall see. We shall see. Since we got 1 viewers right now, I should open it up in another tab. Otherwise, it's gonna hurt my Twitch. I'm gonna open it up. There we go. Mute it. Okay, there we go. Well, it seems like it's frozen or something.
Nope. Start it again. A little bit of a lag, that's all.
Has it got a lot of lag?
A bit of lag, but it could be happening on my end. I notice whenever it lags, if I go to the advanced settings, set the latency to low, and then turn it back on, I get better performance.
Well, I'm just trying to figure out the best ways to fix performance issues. Okay, here we go. Now on Twitch. Twitchy. Okay, give us a second. I'm just going to hop on this wheel. Put that off to the side.
Seems to be okay.
Yeah. Okay.
Yeah.
Hello, Mew Mew. Hi, T Crazed. Hi, Alan.
Hi.
Okay, so now what we got here is we've got this leg to attach, and we're gonna just kind of do the same kind of thing where we pop it on over this little nub there.
And what you may not notice, if you look underneath this, there also is a little bit of a bearing that we printed that goes underneath that can help it keep in place and rotate as well too.
Yeah.
There we are.
That little, it kind of just reduces the friction and also helps the fit, because it wasn't, they're not exactly straight, like, they're not touching directly. It's only that bearing that's touching.
I want to build on this side here.
Sorry.
Yeah, okay.
Okay. Sorry.
That way people can see what's going on.
It looks like the Octoprint stream is frozen.
It has,
Okay, there we go. I'm just going to keep it open because otherwise, apparently it freezes, guys.
I guess, yeah, when it's hidden, I guess it doesn't display video.
Okay, so here we're going to get that in there. And you don't want to over tighten these because they're very delicate. These little plastic servos they're delicate.
Just
but look at that.
Inside.
Now we've got the droid equivalent of a T-pose.
It's a transformer.
It's a transformer. Transformers, robots in disguise. Now I gotta think here. Do I want the wires coming underneath or underneath? Underneath or above?
I think above for now, because if it
then it's
hangs
gonna
down,
plug
it
above,
could get
yeah.
caught, perhaps, and
Yeah. Let's push this through. What's printing on the 3D printer? The thing that's printing on the 3D printer is the rest of the legs that's this thing is missing. So you guys can see that I still am requiring a few more pieces.
You need a few more parts like this. They're being printed right now.
Yeah.
And also little knobs as well too that fit underneath this little hole here. Actually a pivot. Actually, sorry, this side. Actually, only pop one of these out. So one of these is being printed, although this one's stuck inside. Yep, there we are. So currently, we're printing. Sorry, we are printing these.
Hello there.
Currently.
Hi there, Experience Network.
So these are the shoulders for our print. This is a little plastic bearing that fits on inside. Goes right into this little hole here. So I'll pop this in like that. So it rotates and acts like a bearing, though this one's a little tight, so I think I need to kind of fix this up.
Yeah.
Yeah. So
Although it doesn't need to spin that well. Really, the thing that happens is that it just really pushes it like a quarter of a millimeter out. That makes it all fit together.
let's just reduce the friction a little bit. So take my deburring tool and just rotate around like that.
An army of them? That would be great. Our hope with this one is that I really want to give it a brain. I want it to be smart. I want it to be a smart little droid. So my hope is to give this guy a smart little brain, like a Raspberry Pi or something like that. Okay, so unfortunately, that's pretty much all we can assemble for now. But I need to attach them together.
Okay.
I got to put it together. But what we can do is we can get to going on the software, I guess.
Okay, so I guess we can give people. Actually, we should point people to the Thingiverse page.
Oh, right, yeah,
yes.
yes.
Design and tell
Right,
everybody to know what the aim of this is going to look like.
Right, yeah. There we go. That's in there. Sorry, I'm just trying to get it all set up. The Thingiverse. Come on, add.
So, giving everyone a good look at this. So we have essentially our backbone and the two supports on the side. And these are the legs, which have 2 degrees of freedom. They can rotate this way, like this, and they rotate up and down as well too. Although I think maybe you have to adjust where it rotates to. Same on this side. It rotates left, right, and up and down. So when eventually it walks on the surface, it's able to crawl on the surface by moving its legs sideways and up and down. And of course, there's another set on this other end.
That's going to be the next step once we got everything all plugged together. Now, I actually do have some parts that I've already created for getting it together. So this is the guts right here. This
Move things out of the way.
is how the whole thing is going to run once we've got it all settled. So one part of this.
I guess you can discuss what you've done here.
Okay, yeah. So there's
it up here so people can see.
This board here is like an Arduino. It's the microcontroller. It's got the memory of how to walk programmed in it. Well, actually, it doesn't actually have that yet, but it's going to have the program in it that does all of the walking and all of our software that makes it actually run. And the long dangly thing that's dangling from it, this lets us upload code to it. This is kind of like, on a normal Arduino, this is actually part of the board, but because this is a hacked
serial
Arduino.
connector, so what we have here is we have an actual a little microcontroller
Yep.
at Mega, I think, right?
At Mega 328P-PU.
So this particular chip powers, if you're not really familiar, there's something called Arduino Ecosystem. So back roughly a decade ago, a bunch of Italian hardware designers decided that they needed cheap computers for students to play around with. That way they didn't have to buy expensive multi-$100 computers in order to work on hardware projects. So they came up with Arduino, which is roughly about, the original one was the Arduino Uno, roughly about $25-$30 US or so. But essentially had a whole bunch of pins, and you could easily plug into a USB connector to a computer and program it. This is essentially the stripped down, hacked version of it. If you look in the back, we just essentially, soldered wires together to make everything work.
It's hacked, we know.
Yeah, hacked, we know. Why do we do this? We're cheap, that's why.
Yeah. You could spend like $15 to $20 to buy an Arduino, or you can buy these chips. They just bring the chip really close.
How much did you pay for those things?
I'd say that with shipping, they were like $2.50 each. Yeah. And like I buy them like 10 or 20 at a time, so that I'm only spending like, what is it, $25 for 10 of them. And yeah, they're cheap. Oh my god. Mm-hmm. They're very, very cheap, and they work good.
Yeah, you're willing to,
However, I would like to one statement about this is that not all Megas were created equal. So sometimes you'll get a batch of them that's really good, and they're all amazing, and they're all working perfectly, and then sometimes you get a batch of them that you have to complain about. So yeah, be careful where you make sure you buy your Megas from a reputable seller.
And then we should discuss what all the rest of the stuff. So that's the brains of this. So it's a 16 megahertz, roughly 16-bit CPU as well too. So it's
you can use our Arduinos for all sorts of fun projects. I recommend anybody who wants to get into this buy an Arduino to start, because that's how I started. And then once you've kind of got used to it and you want to have more Arduinos for more projects, that's when you start to learn how to do the Arduino standalone. So if you Google Arduino standalone, it'll show you how to set up just the chip on a breadboard, and from there you can start hacking away.
Yeah, it's very minimal what you need. We have extra stuff that's not quite necessary, but it's nice. We have a crystal, that's the clock for this thing that makes it work at 16 megahertz, but if you're willing to bypass that, you can actually use an internal oscillator. You can skip I think it's about $1 or so for that.
It's like $1 for 6 of them, or
yeah,
like it's $1 for a bunch of them.
Cheap, but if you're willing to be even cheaper, you don't even need that.
Yeah,
it's just a little more unstable. It's just not 100% accurate at 16 megahertz. But if your app or application not time critical, you can get away with just actually, telling it to run off its internal oscillator. You can go really bare minimum if you want to. But let's discuss, what is this thing here? Okay,
so now this thing over here, this is really interesting. This is the TLC 3940 or something like that. Let me read it. Give me a second. It's called TLC 5940. So what does this chip do? This is a chip that allows the Arduino to control many servo motors. Now, some people may ask, some people who are like specialists with Arduino, they may ask, what's the point of that? Considering that this chip can already run a bunch of servo motors. Well, the amount of PWM pins on the Mega here, I think, is maximum 6 or something like that.
6 or so, yeah.
With 6 PWM pins, you can run 6 servo motors. But if you take a look at our quadruped, we actually have 1, 2, 3, 4, 5, 6, 7, 8. Because one more, right? 8. So we actually don't have enough PWM pins to run all the motors that we have. So we're running into some issues where we don't have enough of the specialized pins. Now, PWM pins are specialized pins that allow us to kind of output like a pulse width modulation. So it allows us to like send waves of information, and that's how we are actually controlling these servos. So those specialized pins, if you don't have enough of them, well, you can't do what we want to do with them. So this actually gives us more pins by it uses like a control mechanisms inside of this chip so that you can control many pins with very few pins. So over here, you guys can see these 4 wires that are coming across. With just those 4 wires, pretty much,
That we have is those are.
Or sorry, 1, 2, 3, 4, 5 wires.
Yep. Mm-hmm.
We're able to kind of like send what information we want for each of these PWM pins, and control like I don't know how many this is. 1, 2, 3, 4, 5, 6. Yeah, 16 PWM pins off of only 5 pins.
Yep. So what it is that this thing talks to essentially its own little serial protocol. I think it was IC2. I think. Or I think that's what it was.
Yeah.
Yeah, IC2. There's certain, again, if you work with this kind of stuff.
Wait, I think this one was the other one, not the I2C. The Nokia one. What is that called now?
I'm trying to remember the protocol. It actually supports a couple different protocols, but
it's called it's got master in, slave out, master out, slave in.
Yeah, MISO, the same stuff you programmed.
I'm gonna Google it and find it out for you guys. Give me a second. It's a specific protocol that this chip uses. It's called SPI. It's called SPI, guys. Serial Peripheral Interface. So this thing uses SPI protocol in order to communicate. Really, like, it's a fancy way of saying that...
it's kind of like USB for microcontrollers. That's what you think of it. It's an internal protocol, kind of like USB serial that lets it talk with very few pins, send data back and forth between it and other electronic components, and those can do other jobs. And this particular thing decodes the signals that gets into multiple pulse width modulated pins, which lets us control multiple servo motors.
Yeah.
Or if we wanted, we can actually hook up power LEDs, control lights as well too, tons of stuff.
Now this here is...
That's your power, I think.
I think this is the motor power down here.
Mm-hmm.
This is the board power.
Mm-hmm.
So you guys can see that there's actually 2 different power inputs. I'm just trying to figure out... Welcome to whoever just showed up in the chat. And then I'll have 69 followers. Okay. Welcome to whoever just showed up in the chat. Anybody who's in the chat, guys, hello. Hello and welcome. So here we guys can see that there's 2 different little pins here. There's these ones down here. You can see there's a plus and a negative on them. That's I just know that that's the power supply for the motors. This also allows us to power the motors through the chip. How do I just know? Good question.
You memorized the data sheet?
I memorized the data sheet pretty much. But these ones were already plugged in because...
Well, the other reason we know is that certain reason that you always want to know what is your power supply is, what's ground and what is power in. And tradition, of course, is red for power in and black for ground.
Yeah.
Mm-hmm.
Give me a second. These ones look like they're all power. Mm-hmm. Yeah, those ones are all power. Where's the...
I think it's an external power pack.
Unless it goes up here?
Mm-hmm. Well, I guess we just have to verify our circuit diagram before you actually...
Yeah, I probably should. I'm guessing that it's probably like that.
Mm-hmm.
My key thing is that, like, the power here powers this board, and then the power goes across over into this one. We have 4 viewers? That's incredible! Hello, everyone in chat. Oh, let me pull this one out. And also, I can tell that these wires are like bent on the end. You can see how they're kind of like bent in one direction.
Yeah.
So that gives me a hint that this is probably where they were plugged in before. But in the future, I think I'm gonna want to secure things a little better. But there you go. I think that's plugged in now. And then the only thing that's left is that this guy here, which is the power supply for the motors, would go into that last little button there. I'm not going to plug that in right now, just because we're not going to do that just yet. Unless, should we mess around with some servos?
Well, so we need an Arduino for that in order to get the PWM part. We just have to give...
I mean, can't we plug one of these into this thing here?
We just plug it directly. Actually, we should plug it in here because, again, we don't know the protocol set up correctly. We don't know what the voltages are. So you don't
for this guy? I think I know the protocol for this one.
All right.
This guy's already set up properly.
Okay, sure.
Remember last time we got the quadruped wiggling?
Okay.
It's because it already had a program set up in here in order to...
It just says sweep, I guess.
Yeah, I think it had a sweep in there.
Yeah.
Well, yeah, I think it would just made all of them sweep.
Mm-hmm.
But there is...
We should put a little flag on there. That way we can actually see some activity.
Should I just put this guy in there?
Yeah, that's fine.
There we go.
We should move things out of the way.
Should we just plug in directly into the Arduino, maybe?
This is why I would probably recommend that because it's a known quantity.
Yeah. I mean, I will have to plug all the stuff back in anyways, right? That one?
I'm trying to think. Or maybe it's just already preset. Because
it's pre-set up. I feel like if I unplug it, it's just going to make more work for us.
Okay, so let's actually just try it out. So we'll cross your fingers not to burn anything out. And we'll just...
let me just double check this and make sure that I got everything put together. Okay. So so what I'm seeing here is that over here on this side, this is the positive rail.
Over here, yeah.
So this over here on the left side of the board is the positive rail. So this bunch of 4 pins over here is the positive ones. And then over here is the negative pins. So those ones are across the board. However, if we take a look on the other side, you can see that there's 2 different kind of pins that are coming in here. One of them is coming off of the positive pins, and one of them's coming off the negative pins. So this is the power wire. So I did that correctly. Okay, I have good faith in this, Alan. That I'm not going to burn this out. Let's give this a try.
Sure. We actually might want to go back and make sure your stream on your 3D printer is active. I think
you is it a die?
You must have switched out the tab or something.
Oh yeah.
Yeah, you want to keep the tab active or up front or for the camera.
I feel like we should zoom in a little bit more so they can see it. And let's cut more off the right. Let's do 400 off the right, 300, 500 off the right. There we go.
Oh, that's better.
And then off the bottom, we'll do 200, 300, 400. No, that's
better.
There you go, 350. And then a little bit more off the top. Let's do 300. 350. That's a little much. 400. 300. There you go, that.
Okay.
And then I can go a little more off the left. So let's do 900. A little more off the right. Let's do 600. There you go.
Okay.
And then I can zoom in a little more. That, although you still really can't see it. I feel like we have to crop it even more. Let's crop it a little more. I'll take a little more off the top. It's too much. That's enough.
Yeah, and later on we'll move the camera closer in, actually downstairs. That way you have a bit sharper picture. But yeah, there it is. It's printing the next little bit. Again, it's printing more shoulders and more
I guess I can put it up here. As we get better.
Shrink it down to the same size as us.
Yeah, good idea. Okay?
Move just over a bit. That way it's...
That?
Yeah, around there. Yeah, that way people have all the space down here to see us working on stuff.
Okay, so now this guy here, we've got to plug that into a USB. I'm going to grab a USB cable for that. So I will be...
We have one dangling around, I guess?
We do, but it's currently plugged into the microphone.
All right.
However, we might have another one in one of those boxes over there.
Let me take a look. For a moment.
Thank you, Alan.
Sure.
Experience Network. Undercarp, are you still here?
I have to check downstairs. I think you can just HDMI cable.
Okay, I can take a look too. I think I might have a better idea. I'm pretty sure there's one in there somewhere. If it's not there, then... No, that's not the right one.
No,
I need a serial USB speaker. Here, I'll swap you. Sure. Good idea.
Alright, so... Trying to see our... Trying to set up a working demo.
Oh, there we go. Perfect. Boom.
Okay.
There's a cable. I knew I'll put one aside. I'll put one aside specifically for today. Yay, preparation. There we go. Sorry guys, just failing at USB. Is it Mermco Chops? What's Mermco Chops? What is Mermco Chops? What was that? What was all that about? Okay, it says it's setting up the USB Tiny now, guys. And now let me try and plug this guy in. Huh. Oh, I see. We gotta plug in this too. Smoke test?
Okay. Is that
Maybe
set
it's
plus
not.
or what was that place plus ground? Is it labeled?
It is.
Okay.
It's plus and negative. Huh. Nothing happened. I'm plugged into the first one. Let's try again. Huh. Nothing.
There's a like blinking.
So it's doing something.
Mm-hmm.
That means it's sending a signal of some kind.
Oh.
Uh-oh.
Some was loose. Is that the right orientation?
Signal VCC ground.
Okay. Ground is usually black. Yep, so that signal is orange. Yep, so that's correct there.
It was working last time.
Mm-hmm.
Remember, Alan?
Yep. What is the battery pack is going or something?
Could be the battery pack.
Mm-hmm.
Should we just try it with just the Arduino by itself, maybe?
I would do that to minimize issues that it might be this board or some misconnection between the board.
Yeah.
Potential with more connections.
One thing I gotta do though, I should. I think I already took a picture of it,
Mm-hmm.
but I just double check that my picture is good.
Sure. 5 people on the stream now.
Really?
Mm-hmm.
Wait, give me a second. I'm just gonna take new pictures. What is Mermco chops? I don't know what the.
It's looks like it's or Midco chops.
Is it Mermco chops? Okay, I got pictures of it now. Okay, I snapped some pictures of it. Now I'm gonna disconnect it. Okay. So wait, let's unplug it first before I start ripping everything out. Don't want to like rip out ground while everything's connected. Okay, guys. So I'm gonna put that off to the side. We don't need that just yet.
You've got a breadboard around, so in case we need to kind of extend some wires.
Yeah, I can go get a breadboard. Give me a second.
Yeah.
I just want to. Should I just flash it with just a blink scratch for now?
Let's do a blink set. Just make sure that it can blink first.
Yeah,
Let's
I'll do that. Should I make another overlay for programming?
Let's see, sure, or just, yeah, because I guess we want to have this in front of us. So, programming on this side.
Okay.
Just fill the screen with stuff.
We'll slowly get better where we're a little less cluttered. I think that I could probably make the droid cam a little smaller.
Minimize, I guess, our display a little bit. Possibly.
There you go, like that, right?
Mm-hmm. Well, no, actually, I would go the same size it was. We just put it in the corner where we're programming. Right, we have enough space here to.
Okay, yeah, put it like over there.
Yeah, and we still because we want to see that this blinks as well. So we want to keep this prominent.
Okay, so we're gonna go into Arduino now. Open Arduino. just happened? See that it broke for a little bit? How come that's not showing up?
Oh, that's what it's a Java program, so therefore it doesn't show up properly. It doesn't get screen captured, I think. Oh, it's also it's on the bottom layer.
Oh, I see.
Yeah, so you want to bring it up a level. There, that's why.
And I think we can actually we can flatten this a little bit. Let's add a filter on it. Crop it. Crop is like the most useful filter, guys. If you guys don't have never used crop when you guys are streaming, you guys should. It's really good. 300, 200. I just don't want it to go too much. We lose everything that we're working on. I'm really happy that Baron and Nancy came to join us. Is that good, or should I cut it a little more?
That should be fine.
Should I make it a little smaller, maybe?
Make it smaller, though. That should be fine. It should be visible.
Like there?
It's right there.
Unfortunately, we lost a few of our recent followers. Maybe I'll just move it on top of the build stream for now. There you go. There you go, like that. That way y'all can see what we're doing, okay, guys? Okay, so first thing we're going to do is we're going to just put in a basic sketch here. So let me just grab a blank sketch. Arduino Blink. So I just go on to Google, I Google Blink Sketch Arduino, and I'm going to grab the basic Blink sketch from the website. And I'm going to post it right into Arduino. So now we've got this stuff in Arduino. Let's explain what this does a little bit. Make it a little bigger. So the first thing we do is we set everything up. We make the pins, the pin for the LED as an output. And then in our loop, we digital write the LED as high, so it turns it on. We wait a second, then we digital write the LED as low, which turns it off, and then we wait another second. So that's all this does. So let's just do it. I think this is already set up. Oh wait, no, we gotta change this to USB Tiny. Yeah. Now we can upload it, I think. Upload it. So when I'm using a programmer, I have to upload using programmer, so just do that. I'll have to save it. Libraries, documents. Maybe I'll make a new Arduino. Here we go. Here. Blink. And then I guess I can make this a little smaller. Don't need to see all of that. Hey, Baron and Nancy, are you still here? Why did it say error uploading sketch? You cannot find USB Tiny device. Is it not on the correct COM port? COM1?
Let's see. They come loose? Is it plugged in still?
USB Tiny ISP, right? It's not AVR SP. It should be USB Tiny ISP.
What board are we using?
Nano.
Yeah.
Nano. And we want to use old bootloader. Let's try that again. Because like these chips are really weird, so if I don't use the old bootloader on them, sometimes they have issues. What? Still says can't find USB Tiny device.
So maybe I need to unplug and plug back in.
Yeah, plug it
second. Noise. Plug it back in.
Try again. Upload.
Having trouble finding app Tiny. So actually, let's go to your device manager. Okay. Oh yeah, USB Tiny. It may not have the drivers. Not compatible. Update driver. Yep.
That's so weird. I guess it's like a Windows 10 thing.
I think you might have had an update recently or something that's kind of caused the glitch. So
What do we do?
We're going to have to update the driver, so it's a driver issue. So we have to download a new driver, so we can Google search on USB Tiny driver. Okay, Adafruit, yeah. So let's grab them.
Okay, we went on Adafruit and we're downloading it. Oh, wow. Just to run the AXE?
Mm-hmm.
Okay. Mm-hmm. That seems legit. Hey, guys, I'm going to grab a drink of water, guys. Oh, my God. Apparently I have a drinking problem. Whoa, look at our, wait, give me some. Hold up. There we go. I'm going to pull that one off. Can I add these to this one? There we go. Okay. I just wanted to have our auto print still running there. What were we doing again?
We're installing the drivers for the
right.
USB.
Yes. It's working. Agree. Feather? What is it?
These are the boards from, I guess.
Feather, huzzah.
Yeah, I think these are different brands of USB Time, but I think that one at the top is marked USB.
Feather YCAD.
Number 2.
And then Trinket Pro Trinket / Jamma, USB Tiny ISP.
Okay, let's choose that one.
Okay, install it. Install?
Yep.
Install. Well, let's unplug this first. I'm so confused as to what that means. He said, what is Mermco Chops? What is it? Please explain to me. Okay, it's completed. It has completed.
I have no idea what it is. And now let's plug it back in and just see if it recognizes it correctly. And no error. Okay,
Should
let's
close and reopen this?
Yeah, we'll have to reopen it.
Okay, Sketch, Nano, COM1, USB Tiny ISP, upload.
Upload.
Oh, it seems to be doing a little more this time.
Oh, yep.
Uploading.
Let's check. Oh, blinking. Oh, yeah.
Is it doing it?
Yes, there it is.
Oh, there you go, guys. Take a look. So, from our work here, we've got 100. There you go. So, guys, we just finished uploading the program, the one that we just made, and it's on the board. You guys can see the proof is in the pudding because the light is blinking on and off. On and off.
Okay, now we're going to see if we can just make the circle work. So we're going to reprogram the...
Let me just take a look here. It looks like the auto print froze again. It seems to freeze every single time I close that window.
Yeah.
But it says here, I'm looking at the auto print right now. It says it's going to be done in about 1.5 hours. Okay, guys? So I guess we're going to try and keep the stream going until we finally print that stuff up and we get the whole thing put together. Because I really want to try and get the whole quadruped working and moving tonight. But in the meantime, we can try and get this working well. It seems that
communicating with our existing servos.
This is the basic test that you want to do with pretty much any Arduino. Anytime that you guys are going to do electronics with an Arduino, the first thing to do is do a blink test to make sure that it's working. So I'm going to grab a drink. I'll be right back again.
Back in a second.
That's the first step done. in the chat. Feel free to chat and say hi.
Sure. Looks like back to 4 people in the chat. Just right now, we're just taking a little break while we try to make this talk to our next part, which is going to be this. This is the Pwm Extender.
Yep.
I guess now we can try programming that part now. Do you have a code for this?
Not sure.
Okay.
It's been a while since I've programmed that thing.
Yeah.
We might have to recreate it from scratch. Luckily, it wasn't that complicated, and I just used the basic ones from online. So give me a second. I'm going to put all these away. Clean up my workspace a little bit. And are we just going to put the servo directly on there, or are we going to try and get this thing going first?
Okay, let's just get the servo directly, because we just do a simple PWM on one of the pins.
Yeah, that sounds good.
Right.
Should I grab a breadboard maybe, or
Yeah.
I have to get jumpers, right?
You need jumpers and a breadboard just in case. So we need
Yeah, I'll get both.
Mm-hmm.
I'll be right back.
Sure. So just let everyone know we're attempting to make this robotic platform perform for us. Move things out of the way. So we have these legs, which will turn and move. And twist as well. But we need to control these little servo motors. So right now we're trying to make our little brains, our little Arduino, communicate with these servo motors via this interface board. So we're going to pick up a breadboard, some jumpers, and we can connect these together and do a little testing. I want to make one servo work, and once we have one servo working and we know that's working, we can extend it to the other servos. That's where we're currently at now. Also, what's happening is that we are now also printing additional shoulder pieces for this thing. That's what's happening in this image here. This is our 3D printer, and it's printing our edges. Right over here we have our Arduino window, which we're using to do our coding to make this thing work for us properly. And it's hooked up with this, what's called USB Tiny, with a USB cord to our computer. And so we're just waiting for breadboard and jumpers. And here we are, breadboard and jumpers now.
Got him. Got him. Okay, so we've got some components here now. Got the breadboard. Oh, I guess we can minimize this for now.
Mm-hmm.
And I've got this big case here that's full of all my jumpers. What I'm going to do is I'm going to grab 3 jumpers so that I can jumper off the pins of the servo motor. That looks suitable. And from there,
This out here, move this out of the way. Yep, here we are.
oh, I guess I need actually a male to male. There we go. That's a good one. So I'm just going to put this here. I'm putting the dark wire towards the ground because they're kind of similar. But, again, this is just for testing, so. There we go. I'm so confused as what is Mermco chops?
It doesn't show up anywhere as anything. Do Google search. What is Mermco chops?
That's one of my friends too. That's my buddy Cordell said Mermco chops. I don't know what the.
Google said, do you mean Mimco chops? What are Mimco chops?
Yeah, what did you mean Mimco chops?
Mimco chops. So images for Mimco chops looks like just lamb chops of some kind.
They look like lamb chops of some kind, bro. Okay, so
Mimco packable duffel bag, gym bags.
oh, I just realized something. I had it right the first time. I need the other type of jumpers. Where did I put them now? Yeah, I need these ones. Oh, nope.
We have, I guess, male-female jumpers, or
Male to female. Male to female. Let me double check here. I feel like the first ones I grabbed were the correct ones, but now I've lost them. Oh, here we, nope, that's the mail again. This one's a good one? I think that's the one. Yeah, that's the one we want. That's the one we want right there. Okay. Now, I'm going to plug it all in. Like so. Like that. And then I gotta plug them where they correctly go. So it looks like this one's gonna go to ground, and this one's gonna go to power. So this one's will go here and here. What?
Okay, yeah, it's loose connection.
Yeah, it must be a loose connection.
It's coming from this.
What is that issue? What's going on?
Can you unplug this? Is a microphone some other component?
Whoa, guys. The USB blew up.
Maybe I should unplug the other end. Just do that.
Is my keyboard's flashing on and off. This is the one with the fibrous wire. Or, you know, just tug on it a little bit. Is this one here?
Yep.
You know, unplug that one. Down below. That's my mouse. The one below that is the keyboard.
Try that. I think that was it. Maybe plug into your alternate USB.
What the frick? What is going on, guys? This is nuts. And it looks like my webcam is crapped out too.
Okay.
Can I just restart my computer maybe?
Unplug your devices.
Okay, it seems to be okay now.
Okay, let me plug this back in. This thing.
Okay, it seems to be okay now.
Alright.
Oh, no. Now it's back to being goofy again. Do you think maybe I actually fried the USB or something like that?
Hopefully not. No, next thing, this device, I unplugged this. Is this your keyboard?
That's my mouse.
Plug your mouse into something else.
Sure. You plug it down a couple notches further, it'll go in USB 3. Yeah, down there. Oh, there we go. Now it's good.
Maybe it was your mouse.
Yeah, it was just the mouse. Yeah, the mouse was unhappy. Well, okay.
All right.
The mouse was unhappy. All right. Uh-oh.
Oh. Is it this cable?
Okay, so we got the thing blinking. But now my keyboard and mouse are flicking on and off. So my keyboard's no longer working. Oh, it's on again? Now it's off again. Maybe I should just restart the stream, Alan.
Okay, I wonder what's kind of going on. I plugged a mouse in a totally different place.
It's the keyboard now.
Okay.
Keyboard is this one here. Yep.
We have an overcurrent condition.
Huh?
Yeah, maybe it was an overcurrent condition.
Yeah, maybe. That's what I was thinking. I think that I tried to draw too much power.
Let's see, happy now? Nope, not happy. Okay. So, wow. Sorry, folks. We're gonna have to restart a computer.
Sorry, guys. Okay, we're gonna stop and restart. Okay, guys.